And now it's time for the Teleport session at the Application Architecture Summit, where we'll learn how to bring security to your Kubernetes projects. Let me introduce our speaker today, Jonathan Canada, Senior Solutions Engineer at Teleport. Jonathan, welcome.
Thank you so much.
We're glad to have Jonathan with us this morning. He is a certified Kubernetes administrator and certified Kubernetes app developer. And before joining Teleport, he served at IBM and Palo Alto Networks. So he knows a lot about distributed environments. His session this morning, applying least privilege in Kubernetes. For those of you using Kubernetes for scale and cloud-native apps, Jonathan shares a valuable how-to session for securing Kubernetes. We'll get some best practices for least privilege and zero trust with Kubernetes clusters. And Jonathan's also going to give us a great demo on how Teleport really assists the security process. Just a quick note before we begin, feel free to download Jonathan's slides. You'll find they're really valuable. Just hit the red button on the view screen. You'll also see some links with some great resources also available free for you. And we love questions. So to share yours, just type in the submit a question box. So with that, Jonathan, let me turn it right to you and tell us about applying least privilege in Kubernetes.
All right, thank you so much. So as I get into it, first let me talk about the agenda for today's session. So I'll start with a high-level overview of security, discussing attack surfaces, security architecture, and zero trust concepts. I'll then move into speaking about using a unified access plane, also known as an access gateway, for accessing infrastructure. I'll next discuss native RBAC capabilities within Kubernetes. Then I'll provide an overview of my demo environment as well as the architecture of Teleport, followed by a demo. And of course, lastly, I will answer any questions that have been added to the Q&A chat. So in this section, I'll define a few key security concepts so that we at least have a common set of definitions to work from. First one is an attack surface. So you can see the definition here according to NIST. The real takeaway from this is that an attack surface describes all of the vectors for exploitation. So as you start adding things, infrastructure, people, applications to an environment, that can increase the attack surface and add additional vectors for malicious actors to exploit an environment. This slide discusses the different technology layers that you'll find within an organization. As you look at each layer, you'll want to perform an attack surface analysis for each one. So this first bullet point, networks and infrastructure. Some questions to ask for this are, how are users and devices accessing your networks and servers? Is SSH being used? What other protocols might be used throughout the network? Is it necessary to have all of those turned on? Applications, what applications are you running in your network? Who has access to those? How are those being secured, as well as the underlying operating system and host? And how is that data being protected? Then you have your endpoints. So how do you control which users are authorized to access different parts of your network and the different hosts, the different servers? Lastly, cloud. Are there any misconfigurations throughout your cloud environment? Do you have open S3 buckets? Are API keys not being shared or not rotated? And the point of this is a Kubernetes deployment covers all of these layers. So Kubernetes can have applications running in its clusters. You have to think about the infrastructure that those clusters are running on, and also the endpoints that your users are accessing the Kubernetes clusters from. The last high-level security concept I'll mention here is zero trust. So according to Forrester, these are the three main concepts of a zero trust environment. So definitely keep these in mind as you go about implementing a Kubernetes cluster. And how Teleport can help an organization achieve zero trust based off these three concepts, at least at a high level, is Teleport uses end-to-end TLS encryption. So all resources can be accessed securely regardless of the location of those resources. So even if they're on-prem, if they're in the cloud, Teleport can be used to securely access everything. With Teleport, you can map identities that exist within your SSO to groups that exist within your Kubernetes clusters. So that's taking advantage of Kubernetes native RBAC capabilities, which I'll discuss in a few slides. Lastly, with Teleport, you can capture every single kubectl request, as well as every kubectl exec session. So you can have every action a user takes within your Kubernetes cluster tied back to their specific identity as it is within your SSO. And additionally, have an entire screen capture of what they are doing when they exec into a particular pod. So I'll now discuss using a unified access plane. So when you talk Kubernetes, as I mentioned before, there's going to be multiple layers that you have to think about securing. And also you have to think about multiple clusters. Most organizations will have multiple environments, maybe development clusters, staging clusters, production clusters, etc. You might have multiple clusters per region. But in order to deal with all of these multiple clusters, you really want to centralize the access. So you want to really pipe all of your developer access to your clusters through a single gateway so that you can enforce your policies there. And with that gateway, that's also a great place to attach your single sign-on identities, any requests, and any modifications. So with that, you can get accountability and user attribution from everyone in your organization about who does what and when to your production and staging environments or any other environments that you might have. So you really want to make sure that the gateway only allows SSO users through and records their identity with any of their requests. The other thing too is, even though you're using Kubernetes and it hides a lot of the underlying hardware and infrastructure, as I mentioned before, it's all still there under the hood. So there's still operating systems, there's still applications that are running, there's servers, and you most likely will still manage all of those systems that Kubernetes is running on via SSH or something similar. So you don't want to forget about those aspects. So do all of that same enforcement that I've mentioned for Kubernetes as you do for accessing that underlying infrastructure. So that means attaching your SSO identities to all of your access control. When using SSO identities, you should map users and groups in your identity provider to groups that you create within your Kubernetes clusters. And that group mapping within Kubernetes can be created using Kubernetes role-based access control, which is what I will now get into in these next slides. So this is the Kubernetes definition of what role-based access control is. The point of this is use least privilege and grant access based off of a user's role within your organization. Now, as far as native Kubernetes RBAC goes, the two main ways of doing that are using either roles or cluster roles. So again, these definitions come straight from the Kubernetes documentation. But in my demo, I will demonstrate using a Kubernetes role rather than a cluster role to limit a group to a single namespace. So be on the lookout for that in my demo. So an overview of my demo environment and architecture of how Teleport works. Here on the left side will be me. This is some user who needs access to some piece of infrastructure. With Teleport, you can access SSH servers, Kubernetes clusters, databases, as well as internal web applications. In this demo, I'm going to focus on Kubernetes access. So how I go about getting a kube config that I can use for interacting with my Kubernetes clusters is I will use TSH, which is Teleport CLI tool. So I'll use TSH to log into a teleport proxy that I've set up in my own environment. And I've also set up an integration with my SSO provider. I'm using Auth0. So when I do this TSH login to my teleport proxy, it's going to start the SSO sign-in. So that's going to handle the authentication side of my teleport cluster. The things that I'm actually authorized to access will be based on a teleport role that I'll receive. So with teleport, you're able to map the groups that exist within your identity provider to roles that you can create within teleport. So some of those things you can specify in a teleport role are what users somebody is allowed to SSH as, how long their access is good for, what Kubernetes groups they get to be a part of, and also what labels they are allowed or not allowed to access. So with teleport, you can associate labels with all of your infrastructure and then allow or deny based on those labels. So assuming I have authenticated via SSO, I receive some teleport role that authorizes me to access my Kubernetes clusters. The things that are authorized in that teleport role get encoded into short-lived certificates that are then issued to me. And that also includes a short-lived kube config. So with teleport, you don't have to worry about people sharing their kube configs. Once you have teleport, people will have short-lived kube configs automatically appended to their local kube config. And as I mentioned during my previous slides, every action that a user does using kubectl will be recorded and tied to their identity as it is within your SSO. So you don't have to guess who did this random kubectl create of some resource. You'll see specifically which user did that action. I will now switch over into my demo environment. So in my slide, I mentioned how users will always log in through the teleport proxy. The proxy also serves a UI that can be accessed in a web browser. So this that I have on my screen is a teleport proxy in my teleport cluster. Auth0 is what I'm using for SSO. So if I click this Auth0 button, it does my SSO sign in. I'm going to choose my Google account here for teleport. And when I arrive in here, I've set this up so I have an admin role that I receive. So I'm able to see all of the servers that are part of my teleport cluster, applications that I have, my Kubernetes clusters, as well as databases that I've added to my teleport cluster. And if you'll notice for all of those that I click through, I have labels for each of these. So with these labels, you can associate labels with all of your infrastructure, and then in your teleport roles, allow or deny access based on those labels. So since I'm the admin, I've set it up so I can see everything. What I'll do now is I'll switch over into my terminal window so I can show you what happens when I log in a terminal window and start accessing my Kubernetes clusters in my terminal window. Here in my terminal window, I'm going to use TSH to log into this same proxy that I was interacting with in my Chrome browser. So if I hit enter, it's going to start this single sign-on flow again. So just like before, I'll choose my teleport account. It tells me login successful. So if I return to my terminal window, I can see information about what I'm authorized to do. So what teleport cluster I'm logged into, teleport roles I receive, other information, Kubernetes groups I get to be a part of. And if I do TSH kubels, I'm able to see those same 3 Kubernetes clusters that we saw in my web browser. And if I issue a kubectl command, so a kubectl get pods, you'll notice right now it's selected this first Kubernetes cluster. So that returned information. If I take this to exec into that pod, Teleport is going to capture everything that I do in this session, this exec session here. So if I exit, I'll return to my web browser so that you can see the audit logs that Teleport is capturing. So here back in my web browser, if I go back to the audit log, here's where I can see these Kubernetes requests. So if I view the details on one of these, Teleport is creating these JSON formatted logs. So this was my get, pods, what namespace it was in. And as I mentioned, everything I do is tied to my specific identity. The other thing I can do is if I click this button, this is the playback of when I exec into this pod. This can also be played back in my terminal window. It doesn't have to be in this web browser that you do this. So this time I'll do TSH login again, but I will choose my personal Gmail account that I've set up to receive a role that by default does not have permission to access anything. So if I hit enter, it brings up the SSO sign in again. This time I choose my personal Gmail account. And if I return to my terminal window, here I can see that I've received some role called contractor. If I try to view the Kubernetes clusters that are part of this Teleport cluster using TSH kubels, I can't see anything here. But what I can do with Teleport is I can request a more privileged role. So the role that I'm going to request is a role called dev role. And if I go into my Chrome browser, I can show you what is authorized with that dev role. So here in roles, let me look at this dev role. So when I request the dev role and approve that request, I will be allowed to access any applications that have a label of type equals kube. I will be able to be part of the devs Kubernetes group that I've created in my Kubernetes clusters. I will also only be able to access Kubernetes clusters that have this label of environment equals staging. So as this admin user, if you recall, I can see all three of these Kubernetes clusters. With that dev role, they will only be able to see these two because of this environment equals staging label. So if I return to my terminal window, I'm going to request that dev role. You can see seeking request approval. What I've also done is I've set up an integration with Slack so that any requests for a more privileged role will go through this Slack channel that I've set up. So I can see that this user is requesting this role. Here's a link that I can follow. If I follow this link, it takes me back to where I'm logged in as this admin user, and I can approve or deny this request. I'll approve it. I can provide a message if I want, submit my review. I return to my terminal window. You can see that the approval was received, the reason go ahead, which gave me updated certificates. And now you can see I've received this dev role, which now gives me an additional user I could SSH as well as a Kubernetes group that I can be a part of. And you can see that my access is only valid for about an hour. So now if I do my TSH kubels, it shows those two clusters because they have the label of environment equals staging. And now if I do my, let me first select one of those. So I've selected that first Kubernetes cluster. If I try to do kubectl get pods in the default namespace, it's going to return an error. What I've also done for this user is I'm enforcing per session MFA. So even though they have authenticated, they've received certificates, in order for them to actually use those certificates, they need to either use a YubiKey or an authenticator app of some kind. So I just tapped my YubiKey. And as I said, I'm forbidden from doing that action of get pods in the default namespace. The reason for that is because I've created a Kubernetes role for the devs group, and the devs group is only allowed to do actions in the dev namespace that I've created. So if I do kubectl get pods, specify the namespace of dev, tap my YubiKey again. So now it returns stuff. So this user, they can only be a part of the devs group. They can only access those clusters that have the label that has been specified in the teleport role that they've received. One very last thing that I will show in here is I can also lock a user out. So even though they have valid certificates, I can force them to no longer be able to use those certificates. So if I return to my Chrome browser, or I'm here as my admin user, I'm going to SSH into this one server. So if I SSH, I'll just go as root to use TCTL. So TCTL is an admin tool from Teleport. So I can use this to lock that user. And I'm going to lock them out for 5 minutes. So a lock has been created for them. If I try to do kubectl or anything, you can see that there's this lock targeting me. So in addition to all these controls in place, role-based access control, you can take it a step further and lock users out if you need. I will now return to my slides. To summarize what was covered, remember that Kubernetes expands the attack surface of your environment. So if you introduce a new layer, you have to make some other layer less relevant. So turn off SSH for the majority of your engineering team. Having both present increases the probability of you getting compromised. If you do have SSH enabled in your Kubernetes clusters, make sure to apply role-based access control and synchronize the two so that they have the same authentication gateway and the same access gateway. Access to all your different environments, dev, prod, etc., should all be controlled through the same gateway for access and for authentication. Role-based access tied to your SSO identities should also be used, and be sure to also regularly inspect and audit all access. Thank you for attending today's session. For next steps, here are a few links I recommend viewing. I highly recommend watching this first webinar, Best Practices for Auditing Kubernetes, to learn about additional best practices on auditing, logging, and alerting in Kubernetes. Also check us out on GitHub. And finally, we are hiring for multiple roles, so please join us if you're excited about what we're doing here. Now for Q&A.
Jonathan, thanks for a great session. And we love demos here to see exactly how the frontline folks actually put technology solutions to work. So thanks for that too. Really great session. Thanks.
Thank you.
So Jonathan, a lot to digest here. Just before we get into some of the teleport implementation questions that we have, let's kind of just explore at the first level. You mentioned a couple times Kubernetes expands the attack surface. A couple of comments and notes here. Where do you see the most prevalent vulnerabilities? And if you can, how frequently do they occur?
They occur very frequently. What I see is people using a lot of just default configurations with Kubernetes. think a lot of organizations, as I mentioned in my slides, kind of forget about how many pieces are part of Kubernetes. So the operating systems that Kubernetes is running on, forgetting to patch those operating systems, not limiting network connectivity between different pods, different Kubernetes clusters. A big one that I see is people just sharing kube configs. So they'll create their Kubernetes cluster, generate a kube config that allows somebody to be part of the system masters group, and then just give that same kube config to everyone. So that kube config is now out in the wild. There's no expiration on it, and it has the keys to the kingdom for the Kubernetes clusters. So the big thing is making sure that you're scanning your containers and pods for vulnerabilities, misconfigurations. A great starting place for securing Kubernetes clusters is also the recent NSA and CISA guidance. They came out with a guide called Kubernetes Hardening Guidance, and it was created as a response to the rise in supply chain attacks via Kubernetes. So definitely a great resource to use.
Very good, very good. So let's get into a couple of implementation questions here. And the first one kind of goes to the whole issue of how difficult it is to do access control for Kubernetes without teleport. And I know you gave some good demos, but the question here says, how do you add Kubernetes clusters to a teleport cluster?
There's a few ways to do that. Definitely the easiest and quickest way is we have a Helm chart that installs a teleport agent into your Kubernetes cluster. So the first thing you would do is you would set up a teleport cluster. So you would have your teleport proxy, your teleport authentication server, and that can be located in Kubernetes, that can be located on virtual machines. So if you're in the cloud, EC2 instances, for example. Once you have that teleport cluster set up, when you install the teleport agent into your Kubernetes cluster, that teleport agent, it's installing a teleport pod into your Kubernetes cluster. That pod will then establish a reverse tunnel back to your teleport proxy. Once that's established, that Kubernetes cluster will appear as part of your teleport cluster, just like you saw in my demo where I had those 3 Kubernetes clusters. And then when some user issues their kubectl commands against that Kubernetes cluster, teleport is proxying all of those requests and capturing all those audit logs. Another way is you can take your kube configs from your clusters, you can put them directly onto your teleport proxy. So that's another method of adding all of your Kubernetes clusters. But I think the best way is that kube agent method that I've described.
Very good, very good. And here's another related question on getting started with Teleport. We use a security information event management platform. Can Teleport's logs be sent to the SIEM?
Absolutely. We have several native integrations with AWS, GCP. We've also created a FluentD plugin. FluentD is an open source event handler, so you can use that to send the logs to wherever you need. Also, because most of our customers are self-hosting Teleport, we do have a SaaS offering called Teleport Cloud. But if you are self-hosting Teleport, it's easy to send those logs wherever you need to.
You know, Jonathan, you mentioned SSH. A lot of people are familiar with it, use it. In fact, just out of curiosity, does Teleport support any other protocols?
It does. Supports MySQL, Postgres, MongoDB, Redshift, and we are an HTTPS too for the applications. So if you have internal web applications, you can use Teleport for accessing those. Very soon, we will also be releasing support for remote desktop protocol and accessing Windows servers. So that's something we are super excited about. And we are continuing to work on and will soon be adding additional databases as well.
So, Jonathan, this has been fantastic. I see time is running out, but we can't let you go without giving us a hint as to how folks can learn more or maybe even go hands-on with Teleport. Give us a sense of what the next step would be for our audience this time.
Yeah, so for next steps, there definitely is a trial available for enterprise features. You can go to our website to request more info on that. You can also go to our GitHub repository and start using our open source offering right now. So on there, you'll find Docker Compose examples, Helm charts you can use for installing Teleport into Kubernetes. We have Terraform templates that you can use. So go to our GitHub right now. You'll be able to see all that and right away start using Teleport.
Fantastic. Fantastic. Jonathan Canada, Senior Solutions Engineer at Teleport. Thanks again for a great session. Kubernetes is getting more and more momentum all the time, especially among our audience here at the Integration Developer News, and we really appreciate getting a sense of what the latest way is to make securing Kubernetes clusters really easy. Really appreciate the session, and thanks for the questions.
Thank you so much. I really appreciate you having me here. Thank you.
Our pleasure for sure. Our pleasure. And just a quick note, Jonathan mentioned some great next steps as well as some ways to learn more about Teleport. Luckily, we have most of those right here under the view screen, including that link to the open source GitHub and the free trial. So be sure to take a look at those assets along with the other PDFs we have here in the room. And as you can tell, there is a ton going on at Teleport these days. We didn't have room for everything. So here is a handy slide that'll take you to some other great assets. Just download Jonathan's slides this morning, and all these links will be live. Thanks again, everyone, and thanks for some great questions.